this lesson, we'll be graphing systems of equations to find the number of solutions. At the end of the lesson, you should be able to graph a system of two equations and determine if there's one solution, no solution, or infinite number of solutions. So systems of equations just means that we have a set of two or more equations and that the solution is the ordered pair that satisfies both of the equations. So if there's one solution, on the graph it means that the lines intersect at one point. So the lines have different slopes and they possibly have different y-intercepts. The only time the y-intercept would be the same is if that is your point of intersection. There's also an option of having infinite number of solutions. And this happens when the equations are actually the same line. They may look differently, written in different forms, but they have the same slope and the same y-intercept. To have zero solutions, that means the lines are parallel. So they have the same slope, but they have different y-intercepts. So since they're parallel, they'll never cross, so there will never be a solution. So some examples. We're going to graph both of the equations on the same grid to determine the number of solutions. So in the first graph, first equation, you can see that that is in slope-intercept form. So that means we're going to begin at -2, and our slope is 1, so we'll go up 1, right 1, up 1, right 1. The second one is also in slope-intercept form, so we begin at 8 and go down 4, right 1, down 4, right 1. So your graph will look like that. So you can see that the red one starts at -2 and has a slope of 1. And the blue one begins at 8 and has a slope of -4. So our solution is where they cross right at 2, 0. So if we use that and plug it into our first equation of y equals x minus 2, and I plug in 0 for y and 2 for x, you can see that 0 equals 2 minus 2, so 0 equals 0. So that is a solution to that equation. But it has to work in both. So the second one, y equals -4x plus 8, I substitute 0 for y and 2 for x. I get -4 times 2 plus 8, which means -8 plus 8, so 0 equals 0. So yes, that is also a solution. We'll graph both of these equations on the same grid to determine the number of solutions. The first equation is in slope-intercept form, so we begin at 0, 6. We have a slope of 3, so that goes up 3, right 1. The second equation is in standard form, so that means if we plug in x, y equals 3, and we plug in -1 for x, and y is 0. So those are our two intercepts. So we'll graph those two intercepts and the slope. So the red one you see begins at 6, and it goes up 3, right 1. And the second one has intercepts of 0, 3, and -1, 0. The lines are parallel, so there's no solution. Number 3, the first equation is written in point-slope form. So to graph it, we have to begin at the point 2, -3, and our slope is -2, so that means we're going down 2, right 1. The second equation is in standard form, so we'll plug in 0 for x, and when we do that, y equals 1. And then we plug in 0 for y, and we get x is 1/2. So if we graph those two, we can see that the lines are actually the same line. So that means that there are infinite number of solutions. So looking at these, in this first one, you can see that the lines intersect, which means that there is one solution. In the second one, the lines are parallel, so that means there's no solution. And the third one, it's just one line. So even though they're written differently, they graph the same, so that means that there are infinite solutions. So when the slopes are the same and the y-intercepts are different, we have no intersection, so that means the lines are parallel, and when the lines are parallel, there's no solution. When the slopes are the same and the y-intercepts are the same, that means they intersect everywhere, and the lines are the same, so infinite solutions. If the slopes are different and they intersect at just one point, that means that there's just one solution. So intersecting lines have how many solutions? One. Parallel lines have how many solutions? None.